Hello again, this is Anna Crawford and I'm excited to talk to you today about acid-base disorders. I'm an anesthesiologist. I'm also an intensivist, so I am boarded in anesthesiology as well as critical care medicine. I do most of my clinical practice at Stanford University as well as the Southern District Health Board in Dunedin, New Zealand. I sit on the Committee for Global Humanitarian Outreach for the American Society of Anesthesiologists and serve as the program director of the overseas training program in Rwanda. I do a little bit of work for Gradient Health Systems in New York and am super excited to be part of the Drbeen team here in California. So today we're going to talk about acid-base disorders, starting with pH, what it is and why we need it, the regulation of pH and why we love our kidneys and lungs, and then I'll get into acid-base disorders and the dysregulation and compensation of acid-base. Let's start with pH, what it is and why we need it. pH is essentially the measurement of how much acid or base is in a solution. And you'll remember that the range is 0 to 14, with 7 being neutral. So if something has a pH greater than 7, it would be considered basic or alkali. And a pH less than 7 would be considered acid or acidotic. Most importantly to note is that our bodies, the human bodies, require a pretty tightly regulated pH, and normal pH for the human body is 7.35 to 7.45. So why is this pH so tightly regulated, and why is it needed to be at within that range? So you'll remember that an acid is any molecule that is prepared to donate a proton or receive an electron, and the classic example is the hydrogen ion, whereas the base is just the opposite, accepts a proton or donates an electron, and a classic example here in the human body and elsewhere is considered a base is bicarbonate. So you can add bicarbonate to hydrogen to get carbonic acid, and we'll see more about this equation later. So what's the difference between acidosis and acidemia? Pretty common question and often confused, and I think it's quite important to recognize the difference. Acidemia is a blood pH less than 7.35. So again, our range is 7.35 to 7.45. So if you fall outside of that range on the lower end, it's an acidemia. The process by which that pH is lowered is considered an acidosis. So using similar rationale, what's the difference between alkalosis and alkalemia? Again, alkalemia is a blood pH greater than 7.45, and the process by which that pH is raised is considered an alkalosis. So remember, we talked about carbonic acid. Here's another way to form it. You can actually combine water with carbon dioxide. You'll remember that water and carbon dioxide are the waste products of aerobic metabolism within the cells. So there's tons of carbon dioxide and water generated from all of our cells